Hello with everybody. In this video, I'm going to show how to modify a thermal model of a module to set the junction temperature. This kind of modifications can be useful to generate lookup tables to make tests then with mission profiles. So in this case, I have this device, uh, but if I run this simulation without any modification on the device, I'm going to have this. The junction temperature will vary according to the power required to the device. So if I want to fix the junction temperature to generate lookup tables, we can delete the Cower or Foster networks of this device. So in this case, I'm going to go to the device and PSIM will open a window. Okay, here is open, and I can make these modifications here, but the disadvantage is that I'm going to modify the original device. So here are the thermal informations for this device, and I can change here, eliminate these values, and reduce the number of stages to 1 and collocate all the values in 0. So I'm going to eliminate the thermal response of this device without doing any modifications in the electrical characteristics. So it will obtain the right power losses. So if I want to modify in another device, I can create here a new device and make the modifications, but I'm going to show a simpler way. So I'm going to close it. So I'm going to go to the device file here in this address. So I'm going to go there. Here Altair, PSIM, device, Infineon, IGBT, then FS 100R. FS 100R, I think is this one. 100R W yeah, is this one. So I'm going to open it. You can open with a text editor, or in this case I'm going to open with a Visual Studio. So the syntax here is pretty simple. So in this case I'm going to look for the thermal or Cower networks, the thermal data. So it's here. Here I'm going to change here to 1. I only want one stage, and I'm going to left in blank here all the values. Yeah, right. Then, but I have to save it like a new device. So I can make these modifications in in a new file. It's better. I'm going to copy this device. I'm going to modify the name. In this case, I'm going to click modified. Okay, and I'm going to do the modifications in that new one file. Okay, I'm going to open again with Visual Studio Code, and I'm going to do the same modifications here in internal. So change the number of stage to 1, left it blank again, and it's done. I'm going to save it. I'm going to close it, and it's done. So I'm going to look this new device file. So it's not updated here. I'm going to close the sim and open it again. So I'm going to open here my photovoltaic system. It's just a photovoltaic array connected to a three-phase inverter, and that's all. And it's connected to the main grid. So now I'm going to modify it. It's not finding the device. Ah, right. I forget something here. I'm going to look and again the device is X Infinity. Yeah, it's here. I forget to change the part number, something that it's important here. And so we have two device files with different properties, but they have the same name. So we can change the name there. It's here. I'm going to open again, and I can change the part number here, and that's all. Save it, close, and let's do it again. Let's see if it is updated. No, it is not updated. So I'm going to close and open again. Sorry for that mistake. Okay, open again. Go to the file. And it's here, the device, the modified device, and we are going to check the modifications we have done. so it can take some time. Okay, it's here. As you can see, it has a new part number, a new device file. It has the same electrical characteristics, and it has not thermal characteristics, so it will have not a thermal transient that are usually slow. So I'm going to close it. Now it's verified. Okay, and I'm going to copy this into the 6 IGBTs. Now with the same simulation, I expect to fix the junction temperature of all these 6 devices in 25 degrees. Okay, let's simulate again. Okay, it's simulating here. I have here the response. Just wait. Okay, so I have the current here, the DC bus voltage here, and I'm going to show the conduction losses and switching losses here. Okay, they get the steady state in 0.4 seconds, and what I want to see here is junction the junction temperature. I'm showing just for the first device, but it will be the same for the other devices. So we can see here that the junction temperature is fixed to 25 degrees. And that's all, my friends. You can make you can use these power losses informations for this fixed temperature to generate lookup tables. And that's all. Thank you very much.